Okay, today we're in 11.4, congruent figures. What does it mean for two figures to be congruent?
Identical? Same.
They're identical, they're equal, they're the same. So we're going to start off with some terms here that you're going to hear me saying quite a bit in this lesson. The first one is rigid motion. A rigid motion transformation keeps the original length and angle measure in the figures. So which types of transformation are rigid motions? Translations, reflections, and rotations, which is why this lesson comes after we learned those three. Okay, so congruent figures have the same size and shape, and they are obtained by one of our rigid motion transformations. It sounds real fancy. Go home and tell your parents, I learned about rigid motion transformations today. All right, in math class. All right, it definitely sounds fancy, but it's not too bad. All right, then congruent angles and sides. We're going to talk about that in the next example. They're equal in measure, so we can assume if it's a rigid motion transformation, meaning they're congruent figures, that their angles and sides will also be congruent. Okay, next slide. Okay, so in example 1, we're going to start off by identifying congruent figures in this coordinate plane. And you will have a question like this on your quiz and your test, where you're simply going to say, and I'll give you a little tip in there, you're counting the units to determine which figures are the exact same size and shape. All right, so I want you to take a minute and try to identify those figures. Maybe just draw an arrow between them. I'm going to highlight them. Okay, does anybody see one pair? One pair of congruent figures between the two?
Yes.
Anybody see one, Samuel?
BAC and JKL.
Okay, BAC and JKL. What's my other one, Isla?
PMN and FDE.
Very good, PMN and FDE. All right, so we have two pairs of congruent triangles. So that would be a question in and of itself, both on your homework, on your quiz, and on your test, okay? So that's going to be real important just to be able to identify them. Now, we're going to take it a step further because you have a homework question like this. It's going to be a separate homework question. But it's going to ask you to identify the corresponding angles and sides. The corresponding angles and sides. And what does it mean by that? All right, and this is really important when we're trying to figure out how these figures are actually moving. We have to pick points, the same point, on each figure. For example, point P. Which point on the other triangle occurs in the same location as point P? Just tell me. F, okay? So I would say that angle P, and we're going to use the symbols, so watch the symbols. Angle P looks like kind of like an L. Corresponds, this is a congruent sign, but it also means that it corresponds with angle, what did we say? F. Okay. Now I want to, because we have two sets of of congruent triangles, we're not going to list them all, okay? That would take a lot of time. There would be 6 of them. But on your homework, you will be asked to list them all. So let's just kind of say them out loud. Which angle corresponds with N? E. Which angle corresponds with M? D. Okay, so are we picking up on this? All right. So now let's talk about the other triangle. We'll pick out one pair of corresponding angles in the other triangles, and I highlighted them pink. So I'm talking about BAC and LJK. All right, pick out one pair of corresponding angles. Just go ahead and write it down in that blank space. Make sure you use your angle symbol and your congruent symbol because we know that corresponding angles and sides are congruent. Just pick one pair of corresponding angles from the other set of triangles. All right, Hadley, which one did you pick?
Angle B equals angle K.
Yes, very good. She picked B and K. Do you see that they are both at the tip of the triangles? Do you guys see that? B and K. So we'll go ahead and write that down. Angle B is congruent to angle K. That's a bad angle sign. Did anybody pick a different one? Leah?
I picked angle A is congruent with angle K.
Very good. She picked A and J. And what's the last one, guys? C and L. Okay, so we're getting the hang of congruent angles. Now let's talk congruent sides. And again, on your homework, it'll ask you for all of them, which would be 4. For this example, we'll just pick out one, and then we'll kind of verbally go through the other ones. So side PN. I need to find a side on its corresponding triangle that would correspond with that side length, PN. All right, do you see a side on the other triangle that's in the same location? All right, what side would that be?
FE.
FE. Okay, so PN corresponds with FE. All right, so let's do the other ones. What about MN? MN. Just tell me. DE. What about PM? FD. Okay, now give me one pair of corresponding sides for the other set of triangles. Okay, so now we're back to triangles BAC and LJK. Give me one pair of corresponding sides. All right, there's 3 to choose from. Aiden? BA and JK. Perfect. Congruent to JK. All right, what's another pair, Colin?
AC and JL.
AC and JL. And what's my third pair, Hadley?
I have a question.
Sure.
Could you say AB or does it have to be?
Okay, that's a great question. It can be AB also, yes. As long as they're together, that would be fine. If it was a 3-point angle, we need to make sure our vertex is in the middle, but for just a side length, we're fine. Okay, great question. What's my third side length, guys? BC and LK or KL. Okay, either one. All right, so we just kind of knocked out 2 homework problems and 1 example. All right, okay, not bad. All right, so now we need to describe the sequence of rigid motions. What is that? That's a fancy way of saying what transformations, yes, that was plural, transformations, are happening to get us from the red figure to the blue figure. You see, it's not just one transformation that can automatically make the red one overlap perfectly the blue one. You see what I'm saying? Okay, so there's 2 transformations that have to happen. Here's my advice to you, okay, because this is not one answer is the only answer, which honestly, if you think like me, I kind of prefer those. Like, okay, there's one answer, one shoe fits all, okay? But in all reality, there are actually different transformations, not always, but a lot of times in these types of examples, you could actually do in a different order the transformations. You could do different transformations. So it's really important that you fully see through each transformation. What do I mean by that? Okay, well, the first thing I would suggest is that you make the figures face the same direction. Okay, so clearly this figure is turning at some point, right? And because of its orientation, I know it's not a reflection, right? Because if it reflected the y-axis, it would still be vertical, the red. Y'all follow me? So it is rotating. Now, this is the part where you have to kind of visually be able to tell me which way it's rotating. And there are 2 options. Okay? There's one option, though, that I'm going to push you towards. All right, how could I rotate this so its orientation is facing the same direction as the blue figure? How could I rotate it, Samuel?
Clockwise?
No. Okay, you can do it clockwise, but we're going to do it counterclockwise to keep everybody on the same page. Okay? All right, so here we go. We need to take all 4 of these points and rotate them counterclockwise. How many degrees? 90. One click, okay, puts it in the same direction. 90-degree counterclockwise rotation. Can someone tell me the code? 0, 0 ain't going to matter because 0, 0 is going to be in the same spot.
Change Y.
Okay? Counterclockwise? Flip each ordered pair and do the opposite of Y. We need to actually rotate this. On the quiz and the test, you can write it on your paper. On the homework, you can't write in your book. So we do need to talk about that. Okay? All right, so now let's take -1, -1, 2, 3, 4. -1, -4 is our next ordered pair. And you said to flip them and do the opposite of Y. So now it's 4, -1. So my next point goes at 4, -1. Okay. And then my next point is at -3, -4. So I flip them and I do the opposite of Y. So now it's at 4, 3. All right, so I'm doing this rotation. It's at 4, 3 now. Hold on.
4 be negative?
Yes.
I was like,
No, wait, no, 4 is not negative, but 3 is negative. 3 is negative. The X value stays the same. I only switch the Y value. Yeah, that was about to get real messed up. Okay, so -4, oh my goodness, I cannot say it right. 4, -3. Wait, why isn't this? Okay, there it is. You're flipping the order, reversing them, and doing the opposite of Y. So look here. You flip them. The Y value was -4, and now it's +4. But your X value has to stay the same. Okay? All right. I'm almost done. I've got one more point to rotate. This one up here. -2, 0. Okay, well that's easy because when I flip it and do the opposite of Y, it's just 0, -2. Okay, 0, -2. All right, so there we go. I'm just going to draw a little dotted line just to kind of define it. All right, so it does not change shape. I just did the rotation. Okay, I rotated it. So now it's facing the same direction as the blue figure. Yay, I did it. Okay, but it's still not quite where the blue figure is. So which transformation could just move it on up there? A translation. So how do you know? Okay, you can slide it up now. So we rotated it 90 degrees counterclockwise, and now you can slide it up to make it land where the blue figure is. So now all you have to do is pick any one of your corresponding points. You can pick any one of them. All right? So it does not matter. Pick the top left one. Pick the bottom right one. It doesn't matter as long as you pick the corresponding point on the other figure.
what happened to
So add 4.
We didn't do 1.
Yeah, we did 1, 2, 3, 4. Oh, because 0, 0. 0, 0 was just 0, 0.
Oops.
Okay? No, you're fine. Okay, so pick any one of them and write down the translation. So we're trying to say which type of transformations, plural, are happening between red and blue to get the red figure to overlap with the blue figure. All right, so we said 90 degrees. We're going to do CCW for counterclockwise. That's a long word to spell, okay? Counterclockwise rotation. Okay, and then how did we translate? Did we have to go right or left any?
No.
Nope. How many up?
4.
4 units up.
4.
Oh, wait.
4 units up. Okay, and if you chose corresponding points, let's say you chose the top right and the top right. Okay, they have to be corresponding, same location, and you would count 4 units up. If you chose any other point on those figures, you still should have counted 4 units up. Okay, did anybody else pick a different point on the figure and you still got 4? 2 people? Okay, everybody picked the top right?
Wait, what? Yeah, I picked the top left. I picked the top
Top left. Okay, if you picked the top left, you went up 4, didn't you?
Yeah.
Well, you didn't raise your hand.
Yeah.
So I'm like, either y'all got it wrong or you didn't understand what I was asking. Did you get it right?
Yeah.
Okay, all right, we're good. Okay, so this type of question will be on your test.
Will it be on our homework?
Yes, it will be on your homework. One. You only have one. You only have one. It's not too bad. I did give you the harder of the two, though, on your homework. Okay, last one. This one, you know, okay. It took me a minute to understand exactly what it's saying here. These are the buttons that you can push. Okay? You can push one of these 4 buttons, so you're like literally pushing it to turn the original figure into the image. So it's saying, which buttons would you push to turn the original figure into the image? But then, okay, so this is why the buttons become irrelevant. Then you have to tell me what type of transformation happened. Okay? So, but the button kind of is showing you what transformation is happening. Okay? So, again, that's why I don't really love the buttons part of this, but just look at the original image. Remember what I said, you want it to face the same way first. So how could you make the original smiley face in the same direction as the image? What would need to happen?
A rotation.
Okay, rotation where? Counterclockwise, how many degrees? 90 degrees. Which button would that be? The top right one, okay? So we can amuse them and say, we hit the top right button first, okay? All right, but here's the more important part, and you have a question just like this on your homework. 90 degrees counterclockwise is the first rigid motion for the smiley face, okay? That turns it. But it's still not quite reflecting what the image is reflecting. Okay, so now which button would you hit next, and what type of transformation does that mean?
Bottom left. No, bottom right.
This one. The bottom right one. Okay, notice it's on its side now, but which side of the mouth is the tongue on? Okay, look here. The tongue is on this side now, isn't it? So in order to flip it, it's got to reflect across the horizontal line, which is the bottom right button. Okay? It's got to do a horizontal reflection across the mouth,
Because
the
the
smiley
tongue's on
face.
the wrong side.
The tongue was on the opposite side.
Don't mean tongue.
Okay? So we would say then a reflection across the horizontal line, which, yes, is the bottom right button. All right, so we can get the tongue on the opposite side. Horizontal line.
So the Y? No, the Y-axis?
No, which axis goes horizontal? X. Okay, so that's how I would say it if it was in the coordinate plane, is the x-axis reflection. All right, but it had to make a horizontal reflection to get the tongue on the opposite side of the mouth. All right. I guess a smile in real life because that's emojis.
Really, that's for text. But how? Nobody wants to do that when they text.
I know. Hey, listen, you just gotta go with it. It's a stretch, okay? But it's still multiple transformations, which is why they put it in this lesson. All right, if you understand that, that's it for 11.4.